Okay. So I'll take one more example. Trigonometric function fx equals to sine x. You might be knowing. Let's see what is derivative here. We want f dash x. This is a question. Derivative of sine x with respect to x. So recall definition. What's f dash x? Limit h tends to 0 f of x plus h minus fx upon h. You know very well this is the definition. Limit h tends to 0 f of x plus h minus fx upon h. This is sometimes called, as I told you, first principle. You know, this is called first principle. You are doing derivative by first principle. Okay. So now you know this is a question of what limit involving trigo function. What's the meaning of f of x plus h? In the function, x is replaced by x plus h. So this is sine of x plus h. I hope this is clear to you. In the function, x is placed by x plus h. It's not this, remember, this is wrong. If you write this is wrong. This entire become angle. Instead of x, you are going to write this inner expression, x plus x minus sine x upon you have h. Okay, now you know normally limit question involving trigo should be solved by normally using sine x upon x. Do you remember this limit? As x tends to 0, 1. 10x upon x. This is also 1 as x tends to 0. So we try to set either of this form. What is numerator expression? Is it known expression? Can you just read it? You will realize what is this? S minus S. Yes, what is S minus S? 2cs. Twice cosine this plus this by 2. So 2x plus h by 2. Factor formula. Into sine this minus this. Here angle is x. So x will get cancelled. This is just h. Upon this h as it is. What I did in the numerator, I've used those factor formula. Do you remember? S minus S, which is 2cs. S plus S, you know, 2sc. C plus C, 2cc. C minus C minus 2ss. Right? I've used this. Okay. Now you must have noticed here, this much gives us 1. Right? As h tends to 0, you know the formula here. Limit x tends to 0, sine x upon x is always 1. We know this. So here instead of x, you have h. Sine h upon h and limit tends to 0. This is 1. And in this part, you are going to apply the limit. So here, oh, I'm sorry, here is my mistake. You have by 2. You might have noticed. Because when you do this minus this, then h and by 2, like this by 2. Now, if I have by 2, here also I need to set the same goal. So here by 2 into 2. So now without this 2, this much will be 1. This 2 will get cancelled. And you have cosine, apply h tends to 0. So 2x by 2, which is just cos x. This 2 will get cancelled. So now this is just cos x. So what you have shown? Derivative of function f with respect to x is nothing but what? Here, cos x. I just explained one more time this step. There was my little mistake. Let me write here. Limit h tends to 0. What is s? S minus s, 2cs. Twice cosine this plus this, which is 2x plus h by 2 into sine this minus this by 2. So x will get cancelled, but you have h by 2 upon this expression as it is. Now you know that sine x upon x is 1. Here angle is h by 2. So I need to write by 2. So I need to write into 2. Now this much with limit gives us 1. This is 1. 2, 2 will get cancelled. Apply h tends to 0 here. So what will get? Cos 2x plus 0 by 2. This will be 0. So you are getting cos x. Just for information, here I forgot to write by 2. Okay, so f dash x is cos x. So what you have shown? Derivative of sin x with respect to x, it is cos x. That's what you have shown. This is the function. Dy by dx is cos x here. Derivative of sine with respect to x is cos x. That is, change in the sign represent cos x. Right. So there are some basic examples. Now we go to standard derivatives. So I'll write the standard functions and I'll list the derivatives. Standard derivatives means what? Derivatives of some standard functions. So I'll write here function and here its derivative. Function and its derivative. Okay. So first one, if x equals to c, constant function. You know it, derivative is 0. That is, what I'm trying to tell you is d by dx of any constant is 0. Where c is constant. Derivative of any constant is 0. Second one, if x equals to x raised to n. This is called power function. X raised to n. It's called power function. Derivative of any power function. Like x square, x cube, you did it. If you put n equals to 2, you know. So here, derivative is n into, n into x raised to n minus 1. This comes from that limit formula, if you remember, a into a raised to n minus 1. Take this power in the product and one less power. So what I'm trying to tell you is d by dx of x raised to n equals to n into x raised to n minus 1. For example, what is derivative of x cube? You now write directly. That was by first principle. 3, 1 less power, x square. What's derivative of x raised to 11? That is 11 in the product, 1 less power, which is 10. What is derivative of 1 upon x? You can rewrite like this, d by dx of x raised to minus 1. Fine. Now take minus 1 in the product and 1 less power. So minus 1, minus 1. So you have your minus 1 in raised to minus 2. So what is this? This is minus 1 by x square. I've used this concept only, remember. So what I've shown, derivative of 1 by x is minus 1 by x square. You can use directly. That is, what I've shown, derivative of 1 by x is minus 1 by x square. Okay. Even for fractional power it will do. D by dx of, suppose you have x raised to 7 by 2. So what's the derivative of x raised to 7 by 2? 7 by 2 will come in product and 7 by 2 minus 1. So 7 by 2 into x raised to here 5 by 2. This is the derivative. Right? These are some examples to illustrate this. The first one, derivative of any constant 0. Derivative of x raised to n is n into x raised to n minus 1. There's some examples. Here, one more I can write, that is root x. Derivative of root x. D by dx of root x. Root means raised to 1 by 2. So 1 by 2 will come in product and x raised to 1 by 2 minus 1. This formula. What is this? This is minus power. It will go in denominator. So it will be 2 into, this is minus 1 by 2. If I take over here, it will be plus 1 by 2 and therefore this is root x. So what's the derivative of root x? 1 upon 2 root x. We'll use this directly. What's the derivative of 1 by x? Minus 1 by x square. What's the derivative of root x? 1 upon 2 root x. This comes just from the formula of x raised to n. Root means half power. So half will come in product and 1 less. So this is minus 1 by 2. You take this one in the denominator, so raised to 1 by 2, which is root. So derivative of root x is 1 upon 2 root x. Derivative of 1 by x is minus 1 by x square. Derivative of x raised to n is n into x raised to n minus 1. Derivative of any constant is 0. Okay. Now next standard function I'll write here. Third one, that is I have not discussed, but log x function. I'll just state here. We'll study later on in detail. Log has a certain base. Your base is e. I'm not emphasizing much on this right now. You might be knowing e is a constant like pi. So derivative of log x is 1 upon x, right? Every log has a base. So here base of the log function is small e. This is a constant. You might be knowing constant with approximate value 2.71. It's like pi. You know pi is 3.14. Here it is 2.71. Normally what log table we see, that is under base 10. Here it is under base e. This is sometimes also denoted by ln x. So derivative of ln x is 1 upon x. I'm not getting into proof why it is 1 upon x. But it is, remember, x should not be 0 here. This is sometimes denoted by ln x. What's the derivative of ln x? 1 upon x. Derivative of log x to the base e. It is sometimes denoted by ln x. And what's the derivative of ln x? 1 upon x. Without proof, I'm stating this. It can be proved by first principle. One more, d by dx of a raised to x. This is sometimes called exponential function. I'll write here, a raised to x is called here exponential function. These also we have not discussed earlier. Exponential function. Like this, 2 raised to x, 3 raised to x, 4 raised to x, constant raised to variable. You see the difference between these and this. Variable raised to constant. This is not exponential. 7 raised to x, e raised to x, e is constant as I told you. These are all exponential function. Derivative of a raised to x is given by a raised to x into log a, this number to the base e. Base is e, remember here. If nothing is mentioned, in our discussion we consider base as small e. For example, suppose d by dx of 2 raised to x. What is that? 2 raised to x into log this number 2 to the base e. D by dx of 10 raised to x. What is that? 10 raised to x into log 10 to the base e. D by dx of 3 raised to x. What is that? 3 raised to x into log 3 to the base e. D by dx of e raised to x. What is that? E raised to x into log this number e to the base e. And you might be knowing log of whenever these two numbers are equal, then the value is always 1. So this is 1, remember. This gives us 1. So e raised to x. So what's the derivative of e raised to x? That's e raised to x. This is standard exponential function. E is not any alphabetic, remember. E is a constant with this much value. So derivative of e raised to x is e raised to x. Derivative of, in general, this exponential function is a raised to x into log a. Fine. Now we just list the trigonometric functions here. Derivatives of trigonometric functions. You know there are 6 trigonometric functions. Now you've studied number of things about trigonometric functions. So let me list those derivatives. So derivative of sin x we already proved by first principle, which is cos x. Then sixth one, derivative of cos x, here minus sin x. This can be proved even. You try as I did for sin. Derivative of cos is minus sin. Seventh, d by dx of 10x. This even it can be derived, which is sec squared x. 8th, d by dx of cot x, which is minus, here it is minus cosec squared x. Derivative of cot is minus cosec square. Then 9th, d by dx of, let's write sec x, which can be derived, which is sec x into tan x. And one more, that is derivative of, cosec x, d by dx of cosec, which is minus cosec into cot. These are the standard trig functions, 6 functions. I repeat what I mentioned: derivative of sine, cos, derivative of cos minus sine, derivative of tan sec square, derivative of cot minus cosec square, derivative of sec x into tan x, derivative of cosec x is minus cosec into cot. One thing you should notice if you are confusion, whenever you have c, then you have minus sign in the answer. Derivative of cos is not sine, it's minus sign. Derivative of cot is not just cosec, minus cosec square. And derivative of cosec is minus cosec into cot. So whenever you have c in the function, then you have minus sign in the derivative. So these are the 10 standard functions right now we have. Now we have already discussed working rules in limit. Here also we have some working rules. So we use the standard derivatives and working rules to solve the questions of differentiation, that's the derivatives. So working rules for differentiation, derivatives, which is also called the algebra of derivative of functions. So this is about addition, subtraction, multiplication and division. These are the 4 working rules as we did in case of limits. So d by dx of 2 functions, fx plus gx. So this rule says that you can apply derivative of both the functions separately, fx plus d by dx of gx. For example, if I have d by dx of like this, x square plus 3, then you can write d by dx of x square plus d by dx of 3. Now both of this is known to you. What's the derivative of this one? 2x. What's the derivative of this? Constant 0. So derivative of x square plus 3 with respect to x is 2x. Okay. Same rule is for minus even. If I have minus, I can have minus here. Next is like that limit, if you have some constant into function, then constant will come out and d by dx of function, as we did in case of limits, because differentiation is based on limits only, So some of the rules are same. Constant will come out like this. If I want to get d by dx of 7 10x, so here 7 being constant as it is. If it is alone, then derivative is 0, remember, look at here. If it is constant alone, then derivative is 0. But if it is with the function, then constant remain as it is, just to differentiate the function. So 7 into, what's the derivative of 10x? Now you know, sec square. Okay. Suppose if I want to get d by dx of 9x cube, 9 being constant as it is, what's the derivative of x cube? 3x square. So you have 27x squared, like this. Here this is the constant with the function. So the constant as it is, just differentiation of x square, which is x cube. Differentiation of x square, which is 3x, x cube, it is 3x square. So with this. Third working rule, which is called product rule here. So that's little bit different than limits here. You have product of 2 functions. Now here product rule says that you can differentiate only one function at a time. So fx as it is, d by dx of gx. Plus, always plus. Now interchange. You already did the differentiation of gx, so gx as it is. And d by dx of fx. At a time, only derivative of one function you can do. What's this product rule? fx as it is, differentiation of gx. Order is not important. You can keep gx first as it is. The terms get interchanged. Function as it is, differentiation of gx. Now gx you already did. Now gx as it is, then the differentiation of fx. One by one you are going to differentiate each function. हर एक का derivative करना है, but one by one, not at a time, remember. That's a product rule. Like this. Suppose I want to get the dy by dx of, let's write sin x into x square. Product of two functions, we use the product rule. I'll keep sin x as it is. x square का मैं डेरिवेटिव कर रहा हूँ, तो मैं लिखूँ डी बाई डी एक्स ऑफ एक्स स्क्वायर प्लस, ऑलवेज प्लस. अब क्या करेंगे, वी चेंज द रोल. अब एक्स स्क्वायर एज इट इज कर दो एंड डिफरेंशिएशन ऑफ विच फंक्शन, साइन एक्स. दिस इज व्हाट द प्रोडक्ट रूल. लिमिट में इट वाज लिटिल बिट डिफरेंट, बट हियर इट इज दिस. क्लियर? नाउ वी आर जस्ट writing derivative sin x as it is. What's the derivative of x square? 2x plus x squared as it is. What's the derivative of sin x cos x? This is the required derivative. Product rule. What the product rule says का हर एक को पकड़ पकड़ के डेरिवेटिव करो. इसका भी डेरिवेटिव करो, इसका भी डेरिवेटिव करो, बट साथ में नहीं करना है. जब gx का कर रहे तब fx को छोड़ दो. प्लस when you are differentiating fx, leave the gx. Clear? Suppose I may have like this product of three functions. Suppose I want to get the d by dx of, let's write 10x. I'll write one more, what I should write. Let's write x squared, और एक लिखना है मेरे को. Which function I should write? Let me write log x, no problem. So product of three functions. What I'll do? एक का डेरिवेटिव करो, बाकी दो एज इट इज रखो. आई विल कीप 10x एंड x स्क्वायर एज इट इज. डिफरेंशिएशन ऑफ log x. एट ए टाइम ओनली वन फंक्शन कैन बी डिफरेंशिएटेड, रिमेंबर. ऑलवेज प्लस. अब log x का टर्न आ गया. नाउ इट्स x स्क्वायर का टर्न. सो 10x एंड log x आई लीव एज इट इज. d by dx of which function? x square. Plus now it's a turn of 10x. So I'll keep the x squared and log x as it is. d by dx of 10x. Here order is not important कि आपको पहले इसका ही करना है, इसका ही करना है, anything, because every time you are plus plus plus, remember. Now we just write the derivatives. So 10x into x squared. What's the derivative of log x? 1 upon x, you know. 10x into log x. What's the derivative of x squared? You know, 2x. Plus x squared into log x. What's the derivative of 10x? You know, 6 square x. Fine. So you can simplify, like this x will get cancelled and so on. That's not important. You can do it. The important one is differentiation. Product rule, remember. Okay. Now next, fourth, that's division rule. You have d by dx of division of two functions, fx upon gx. Division of two functions. The gx should not be 0. Okay, now what is the division rule? It's like this. Without proof, again we are writing square the denominator function. नीचे वाले function का square कर दो. Derivative नहीं करना है, remember. Square the denominator function. नीचे से जो ऊपर जा रहा है, that is as it is. Into d by dx of first function, that is fx. Minus, interchange this two. Here your minus sign, remember. In the product rule you had a plus sign. Minus, now fx as it is. And the d by dx of which function? gx. Clear? I repeat. What I did? Square the denominator function. So I've squared, not derivative, remember. Square the denominator function. gx as it is. Always first you are going to differentiate the numerator function. If you change the order, your answer will be different here. Because here in the middle term, you have minus sign. In the product rule, it was plus sign. That's why. There you can change the order. You can take this first, you can take this first, you can take this first. But here you can't, because here you have minus sign. Now differentiation is done of fx. So here now fx as it is, and the differentiation of gx. It's so simple. So let's write one example. You will realize d by dx of, let's write x squared upon 10x. Division of two functions. So I'll use division rule. What's the division rule? squared the denominator function, so squaring. Tan x as it is here, d by dx of which function? Fx. Fx means numerator function. Minus, now which function as it is? x square, क्योंकि यहाँ पे x square का डेरिवेटिव आप करने वाले हैं. d by dx of which function? tan x. So just do the differentiation. This tan square as it is here. There you are not done differentiation, remember. What about this? Here tan x as it is. What's the differentiation of x square? 2x. Minus this x squared as it is. What's the derivative of tan x? 6 squared x. Fine. If you want, you can take just x common. That's not important. 2 tan x minus x sec x upon what we have? Tan square. This is derivatives. You see, you wrote d by dx in front of this. This is the derivative. Derivative by division rule. Fine. So you can try some examples from 13.2 if you are interested. You can try question number 9 and question number 11. Very simple questions. Try at least 9th and 11th from exercise 13.2.